Hey everyone, this is adding and subtracting rational expressions. So I'm going to go through an example of subtracting rational expressions with you guys, okay, and adding will be very similar, okay, and I'll kind of explain the differences as we go through. So let's suppose we have this rational expression, x plus 9 over x squared plus 2x minus 48, and we're subtracting another rational expression, x minus 9 over x squared minus x minus 30. So just like we've been discussing, rational expressions work very much like fractions, and if you recall, when you're adding or subtracting fractions, you are required to have a common denominator. So we are going to have to figure out a way to come up with a common denominator somewhere in this problem, because you're going to notice that our two denominators are clearly different, okay? But since this is a rational expressions problem, the first step we're going to want to do is to factor. So I'm going to factor the first one over here. So we have a sum of 2, a product of negative 48, and that means the two numbers that we're looking for are 8 and negative 6. The second one I'm going to do over here, sum is negative 1, product is negative 30, which means that the numbers are negative 6 and positive 5. So that means that the bottoms are going to factor into, okay, we'll have x plus 9 over x plus 8 times x minus 6. And notice that we didn't have to factor the tops because the tops are not really factorable, right? They're their own factors already. And the second one is going to be x minus 9 over x minus 6 times x plus 5. Okay, that's what we end up factoring them into. All right, so now that we've fully factored, this is the point where we're going to want to come up with a common denominator. Okay, so to do that, I want you guys to take a look at the two denominators that we have here and here. All right, now you're going to notice that both of the denominators have one factor in common. They have x minus 6. So both denominators have x minus 6 in them. Okay, the first one, so this guy over here, is missing x plus 5 from the second one. So it's missing this factor of x plus 5. That's the one that the second has, but the first one doesn't. Okay, and the second denominator is missing the x plus 8 that's over here. Okay, so we're missing an x plus 8 right here. Okay, so what we're going to want to do is we're going to want to place into the denominator of both rational expressions the factors that are missing from the other one. So what does one have that the other one doesn't? We're going to have to place it in there. Okay, so the first one, again, the first rational expression we said is missing a factor of x plus 5 on the bottom because it does have the x minus 6. So we're going to multiply on the top and the bottom by x plus 5, and that's going to look like this. We're going to have the x plus 9 multiplied by the x plus 5 that we're missing, and we're going to be dividing by x plus 8 times x minus 6, and then times the x plus 5 that we were missing on the bottom. Okay, so now the denominator does have a factor of x plus 5. Okay, the second one, the second rational expression over here was missing a factor of x plus 8 on the bottom. So we're going to multiply the top and the bottom by x plus 8. So we're going to have minus, and then x minus 9 times x plus 8, which is the one we're missing, times x plus 8 times x minus 6 times x plus 5 on the bottom. Okay, so take a look. Now that we've multiplied the first rational expression by x plus 5 on the top and the bottom, and the second rational expression by x plus 8 on the top and the bottom, we have exactly the same denominator in both the rational expressions, right? We have x plus 8 times x minus 6 times x plus 5 for both of them. So we've created a common denominator. All right, so the next step is going to be to expand out the numerators of both our rational expressions. Okay, so for the first one, we're going to do x times x, which gives us x squared, 9 times x, which gives us 9x, 5 times x, which gives us 5x, and then 9 times 5, which gives us 45, and that's going to be over its denominator. We don't really need to expand out the denominator. It's not really going to serve a purpose here, so we're just going to leave the denominator. All right, for the second one, we're going to have our minus x times x is x squared, 8 times x is 8x, negative 9 times x is negative 9x, and then negative 9 times 8 is negative 72. And again, that goes over the denominator, which is common. Okay, so I'm running out of space on this page, so let me just create a new page and add in this same line. So this is the line that we just wrote down. Okay, so x squared plus 9x plus 5x plus 45 over the common denominator minus x squared plus 8x minus 9x minus 72 over the common denominator. Okay, at this point we have some like terms that we can combine in both rational expressions. So combining the like terms up top, we get x squared plus 14x plus 45 over the common denominator of x plus 8 times x minus 6 times x plus 5. And in the second one, so we're going to have minus x squared minus x minus 72 over our common denominator. Okay, so now that we've fully expanded the top, so we have a common denominator, at this point, if we were talking about a regular fractions question, you could pretty much just add or subtract the numerators and put it over the common denominator. And that's exactly what we're going to do here. Okay, so since this is a subtraction question, we're going to be subtracting. If it was an addition question, of course, you would just add, right? But what we're going to get is x squared plus 14x plus 45 subtract x squared minus x minus 72, right? So we subtracted the two numerators, and we're putting that over our common denominator. Okay, so now we have some, since we're subtracting up top, we have some more like terms that we can kind of combine. So we're going to have x squared minus x squared, right? Those are going to cancel out. We're going to have plus 14 minus negative x, which is going to give us 15x, and then 45 minus negative 72 is positive 117. So we're going to get 15x plus 117 over x plus 8 times x minus 6 times x plus 5, okay, which is our common denominator. Okay, so at this point, now that we've combined any like terms up top, what we would really have to do is we would have to make sure that we've fully simplified, that there are no common factors between the top and the bottom. Well, 15x plus 17 isn't actually factorable. It's not common factorable or anything, so it is its own factor, and clearly it's not a common factor with x plus 8 or x minus 6 or x plus 5, which means that there's going to be no more canceling, and this is fully simplified. Okay? The only thing we're missing now is our restrictions. Okay, and our restrictions are going to be, just like usual, the values of x that would make the denominator equal to 0, and that would mean that we would have x cannot be equal to negative 8, negative 5, and positive 6. Okay, so this has been adding and subtracting rational expressions. See you guys tomorrow.